to automation and deployment since I left this part for the last moment, since I was almost sure that we'll have had a lot to say about virtualization and containerization, and it's very hard to treat this subject, so few time. So automation and deployment. Well, I can go straight to Ansible, but maybe I can give you just an overview of why we want to automate and what are the challenges that you will face when you will want to deploy some HPC solution. But this can apply to everything. It's not only for the HPC context. So what I will attach to explain you today is give you the bolt and nuts to be a bit more comfortable with automation and Ansible in particular. And then explain you in detail how the deployment process will work, and it's the case for almost all HPC deployments. So I hope you will have at the end good idea at least of how it goes. So why automation? And we'll see after the particular case of Ansible, and we'll tell you why Ansible is really a good choice and how it has been, I would say, a kind of de facto standard for ex nihilo automation, I would say. So I mean for case or there were nothing existing before. So if you start from scratch and you have the choice, I would clearly advise you to go for Ansible because of its power and because of the simplicity of use, I would say, a relative simplicity, but it's easy to access. It's very accessible, and it has been made and designed to be used and usable by people that are not coding guys. Because if you compare to other solutions, I can take use of, such as, well, the historic one is CF Engine, which is still very popular in a lot of data centers. But, sorry.
We can't hear you, Camille. Hello? Are you still here, Camille? I think yes. Hello? Network. Yes, I think it's a connection problem. I send him a message. Camille? Yeah. We are trying to send him a message.
Sorry guys, it seems I lost connectivity.
Hello? Yeah, we can hear you now.
You can hear me back. Right, right. Nice. Okay, so I was about to say, I was saying, okay, I don't know exactly where you did lost me. I'd
I
say,
think from the
okay,
beginning.
oh, really?
Yeah,
Okay,
from when you
sorry for
shared
that.
your slide.
Okay, all right, so I come back to my slide. Okay. Yes, well, so I come back from the beginning. With tendering and Ansible consideration, I would say why you need automation. You need automation for quality and reproducibility. Um, you can make comparison with if, for instance, let's say you want to build a given object, you have a choice to build it by yourself, to give it to build by a craftsman. And what I was trying to explain is that even if you choose the most experimented craftsman on the world to build your parts, if you order, for instance, let's say 1,000 parts, you cannot make sure that even the most experimented craftsman will do in a reasonable delay 1,000 strictly identical parts. You will have slight differences, and you are not sure that it can an error can happen, and if for some reason you want to change something, it will take an incredible time to come back to each build to correct it. So that's where the automation becomes very handy. When it comes to provisioning, to configuration management, or deploying something, you will need automation. You will want automation. And it also can help you to get your server as stateless as possible, a bit like if you treat them as containers. I will explain that. I mean, especially in HPC or in a world where you have a lot of parallel things, automation is really indefinitely what you want to get, because you would, in an HPC cluster, most of the machines are strictly identical. Only differences are the host name, the IP address, and things like that. A few vars. Okay, and automation is really the choice to address this kind of cases, because you can address hundreds of machines almost simultaneously and make sure that they have exactly the same configuration as desired. So using Ansible, you have an incredible level of power on your equipment, as long as you can put your hands on. So I mean, Ansible is very powerful, but it's not too much complex compared to CF Engine, Puppets, and Salt and Chief and other solutions. It's I would say it's very accessible as long as you understood clearly how it works. And that is why this is a choice which is made by most of the industry, especially when you start from scratch, when you have not an existing automation. If not, I know a lot of customers that had existing automation solution, which are waiting to switch to Ansible, or which are still in the middle of migration to an Ansible automation base. So what makes it different compared to other provisioning solution? Mainly, I would say its versatility, the fact that it's pretty accessible without having a lot of knowledge in coding. It is focused on system administrator side. Mm. And starting from that, it explains that it can be a bit too much edulcorated also in some way for some people, but you still have a way to do your things, because Ansible comes also with a very powerful template engine, which is called Jinja 2, and which is not only used by Ansible. Jinja 2 is basically a Python-based template engine. So for the one who are already familiar with PHP or server-side languages, template must be familiar. For the one which are not, we can explain very quickly what it is. Um, template engine is something that will attempt to interpret generate or I mean, yes, a text-based file with special beacons on it that will be substituted with variable or with entire code. So it means that a bit like what you could get using server-side language like PHP or Perl on server side, you have your code which is written, and at the runtime, the file which is a template is passed by the template engine and is producing an output which is the result of the merge of what you put in your template. So keywords are substituted or variable are merged, and conditional instructions and so on can be inserted inside. So it makes Jinja a very powerful template engine, and this brings the power to Ansible. So there's a lot of generic things to say regarding automation, but unfortunately, not only we have not time, but it would require that, or maybe it's already the case for some of you, but it would require for you to appreciate it so that you to be already familiar with some automation. But I can give you a quick overview, but I don't think it's very it would be more efficient when you will already working a bit with it. However, I will try to now to highlight the key points that make Ansible really different. And we're gonna discuss that. So first thing you have to know is Ansible is Python. All Ansible is Python based, and it's interacting with the target. What I call the targets is the host, the servers you want, or the equipment. It can be also a switch. Ansible can address switches, routers, whatever you want. It's very versatile. You have a lot of connectors that permits it to interact with even the most old hardware can be automated using Ansible if you know how to do it. But basically, in the most common case, you will use it using SSH transport, and I would say the process is still the same. You will execute a kind of script, a kind of cookbook, which is called a playbook. So playbook is a notion that you will see in Ansible, which is basically a kind of cookbook, I can say, with task and a few vars inside. And so everything is easy to read. We're gonna go here to show you an idea. And basically it will connect to the target, which is a machine or group of machines that you want to to execute something on it, and it will connect in SSH and use Python as an interpreter to execute, to translate what you've written in your playbook in Python instructions that will execute the changes you want to make on the machine. It can be editing a configuration file, it can be install package, it can be a lot of things. Ansible is very, very modular. So there is almost a module for everything. But I will not go further inside the deep in detail inside Ansible details. But you have to know three major components that you want to know as a system administrator. The first is inventory. Inventory is a place where a kind of a host file, but a bit more evoluted, where you put all your targets and you define your groups. This is very powerful because when it comes to automation or every kind of deployment, you will want to get an easy access for targeting your targets. I don't know if some of you are already familiar with what we call GPO in Windows Active Directory terminology. But with GPO, it's basically some policies that you apply, some group policies that you apply to object into a directory, Active Directory, which is a kind of a LDAP at the end, right? And then as the same as you would have with GPO, with any automation tool, you need to be able to target very precisely what you want to target. So this is accomplished by defining groups, by defining an inventory, and this inventory will contain some host and some group of hosts. This is called group inventory groups, and they are more or less, I would say, static by opposition to dynamic groups that we'll see probably later. But for now, retain that you will mainly use static groups that have been defined in this inventory. For instance, in the context of an HPC cluster, your groups could be GPU node, compute node, login node, management node, etc., etc. So you won't want to address individually one node. You talk to a group. Okay, you want to apply. Okay, I want this configuration on this kind of node. This is purely the orchestration part of automation. And this is what makes Ansible very, very powerful, because I cannot extend longer on it, but this is a key point in automation, and especially in Ansible. If you have one thing to consider carefully, it is definitely your inventory. It is very powerful, and there's a lot of things you can do with it. And more generally speaking, I mean, host targeting is one of the very powerful aspect of Ansible. Another specific things to Ansible is that it is purely agentless. It means that it can operate with a bare metal or nude host. It just needs SSH and that's it, and Python. SSH and Python and you're done. Even without Python, it can run. It can run against a raw bare metal switch, for instance. It can run against a Cisco if you're willing to attempt it. But just for the story, I started with Ansible because with my colleagues we had previously an automation solution, and with network department, I mean corporate network department, we had a story because we were not using the same management tool for our network configuration, and the network was using one tool and we were using another tool, and plus again another for our Windows host. And the thing is, the goal was to look for a solution, a universal something that could be handled by both network department and both infrastructure department and others. And that's how we came to find Ansible. And this was the only one that, and I think it's still the only one that can work purely agentless. What is an agent? Uh, Maybe I forgot to say. An agent is what you will need uh, with most of the other automation solutions, such as CF Engine for the most famous of them, or Puppet. Uh, Maybe it changed, but since very recently, this could not work without an agent on the other end. It means that you have to deploy something on your client at the beginning to make it work, to discuss with the control workstation, with the orchestrating, with the station you will use for deploying your automation. So the big force of Ansible is to be agentless. So it doesn't require something else than a proper SSH access and a Python to run, or even no Python if you are using a special transport, or if you are dealing with switches, network equipment, or so on, which don't have a built-in Python runtime. So this is pretty versatile. Okay. Now, another important component is roles. Roles are a set of tasks, a bit like what you would find in a playbook, which playbook is a set of tasks also. But role is a wanted. You can compare it that for those who are practicing coding. Roles should be seen as libraries. If you make an analogy with the code, okay. Roles are libraries for Ansible, or macro for the ones that are more familiar with macro term, or function if you prefer. It's a set of codes that you will, or routine, or something that you want to reuse very often without having to go in detail in the complexity. Let me take you an example. For those not familiar with library or not convinced of the use of that, for instance, if you consider any program that is written in C, which is interacting by way or another with a screen and a keyboard, is using a very famous library, one of the very first in C, which is called stdio.h. This is the very first library that every developer, even without thinking to it, will use when you write a C program. Because without the stdio, you won't manage any standard input and output. This is a very basic. That you won't write, even you won't compile any C program without that, unless that your program is not meant to interact with the outside, which is very rare, not to say impossible. And you can imagine that this library exists till I would say till the 70s, but yes, same age in the C language. You can imagine that someone that wants to write a C program will not be happy to rewrite everything from the beginning, to catch the IRQ, to catch every keyboard strike, etc., etc., and to manage console and etc. So you want to get rid of all this code, so you will use a library for that. Okay, I hope it illustrates my what I mean. It is also called a function. A function in a code is a set of code that you write, or a macro that you can call later. So a library is just a set of functions that has been externalized. So you have to see roles as Ansible libraries. Definitely. Okay. And this is where you will put high-level task or specialized task that will be called afterwards by a playbook. And the very good benefit to use libraries, also, sorry, I forgot to say it, is if you improve it. For instance, let's imagine that everyone codes its own code to do the same thing. Imagine that there a major flaw is discovered. Imagine the works you will have to patch every single program that will use a similar code. It would be just unfeasible. By using a libraries mechanism, if you improve the library or if you fix a security flow or whatever improvement, everyone which is dynamically loading this library will take benefit of it. I think it's a good reason to use roles, libraries, and so on. If not, you will be forced to reinvent the wheel from the beginning every time. Even if you are alone to write your code, to maintain your code, you will not be happy to write the same thing every time. Especially when you bring an improvement to it, you won't be happy to go to each of your code to update the same stupid thing. So, but if you write it in a library, if you externalize it in a library, if you improve it, if you fix a bug or so, everything that makes use of this library will be updated. So that's how you want to see library in general in coding context or in Ansible context. It's exactly the same. Okay. Playbooks. Playbooks are basically a list of tasks, of direct tasks that you can put a row in a playbook or roles that are actually a list of tasks that you want to carry on specific targets. Okay. And all of this is using Python and SSH. So you can manage that on a very minimal OS, just a freshly installed OS with very essential is enough. So you just require, I mean, as a default, SSH and minimal Python. But you can even be more rows than that, and as long as you can access the host by a way or another. SSH is just one transport between other for Ansible. It is the most common for sure, but it is just a main connector, I would say, a transport, you say in Ansible terminology, and there is others. And you can also indeed extend Ansible with your own. You can do a lot of things. You have also a lot of strategy for execution. For instance, if you have, I would say, 1,000 hosts, and you don't want, you think it will going to be too much load for you or for your management machine, you can slice your job and say, okay, treat them by 10, by 20, or treat them by percent, or treat them by whatever you want. Or you okay, I want to access all the hosts that are Red Hat based and that are of type login and that are made of that, of that, of that. You see, this is an example of targeting. I'll say, okay, I want to reach all hosts that belong to specific subnet or all hosts that are belong to this kind of type, or all hosts or groups that are running Red Hat or Debian or whatever. So the targeting possibility are infinite, and they can be combined together, a bit like if you do an SQL request. Okay, a database request using SQL, except it's that the query language is much more simpler. All right, let's go quickly in inventory. All right, so here what you can see is Ansible format, or so maybe some of you are already familiar with this syntax. If not, you will get very familiar very soon, because this is a YAML, okay? Y-A-M-L, YAML. So YAML is everything except a programming language, just to make sure for everyone. So it's a bit abusive to say, okay, YAML code. We used to say, I'm the first one to say, okay, my YAML code, all right, fine. But strictly speaking, YAML is not a programming language. You have a very limited conditional structure and things like that you can do in YAML. But it's a markup language. By the way, I think it stands for yet another markup language, if I remember well. It's a bit like it's a markup language in the same ways as Markdown is a markup language, if you know Markdown. Or HTML is also a markup language. Okay, it means that this is languages that use kind of beacons to specify words and are used to give a standard formatting of text. Okay, and also one of your next best friend is JSON. Okay, JSON, not like in the Bible, but JSON. JSON stands for JavaScript Object Notation. Basically, I don't say you have to forget about XML, but you can consider that JSON is the new XML. Every aspiring API or whatever or blah 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 guru should know about JSON. If you want to play with something which works with API, you have to be comfortable with what is JSON. If you want to make advanced stuff and cool stuff with Ansible, you have to be comfortable with JSON. JSON is the new standard for exchanging data between machines. It is the new XML. If you know XML, which stands for Extended Markup Language. XML has been the de facto standard for web services for years. It was good at the time. It has still been a bit of pain to parse. As I would say that as a coder. It is very verbose also, and it's less flexible than JSON is. So definitely, when it comes to exchange streams of data in human readable format, or if you are looking for a common exchange language from machine to machine, application to application, or if you want to know what is the standard between REST API, which is basically all of modern applications, web or not, are using that. So you have to know about JSON, right, guys? JSON is your next best friend. Unfortunately, I do not have an example, but at least you can see a lot in JSON. It is very powerful. It is based on Node also. And everything related to JavaScript from way or another will be using JSON for sure, but not only. Ansible has nothing to do with JavaScript, but JSON is just so much powerful for data representation that this is now the choice. Okay, so JSON must be your best friend, even more than YAML. YAML is very basic. It's very basic, but it has a few to know about YAML. Okay, that I will try to explain you here without going too much in detail. But here you see MG compute is a group, children is a keyword, and equipment type C is the value of children. So MG compute is a group name. Children define that there is a children group which is called equipment type C, and host, all that is YAML, okay? And host is a key with C001 as a value. And this, what you see here in YAML format, is a kind of dictionary, okay? Dictionary, the guys who are comfortable with Python should not be surprised here, but for the others, dictionary is a kind of a variable, multiscalar variable. So you can have normal variable, list, and dictionary. So this is a dictionary, but don't worry too much. My colleague Benoit will come back with a few good explanation on this. I hope at least, but I'm pretty sure I will explain you the different format and how to be comfortable with it. But if you have to go in that, I'm pretty sure you will understand quickly, but please take time to not ignore all these subtleties. As for a lot of things, Ansible can seem easy at the very beginning, but it can be a bit complex if you ignore the very first steps. So it's, even if you feel yet that you already arrived or you know similar tools or whatever, it's always good to take time to understand the data structure and make familiar with this data structure. If not, you will go in a few headaches when you will try to parse your variables. Okay, so I'll try to be a bit quick. Here, it's typically a host definition. Maybe you already guessed it. So MG Compute is a group that will handle all the management. It could have been Toto or whatever. This is not a reserved keyword. This is a value. Children is a reserved keyword. Okay, it's reserved to say, okay, MG Compute is a group, and this group has a child, which is equipment type C, which is already a group, and this group has this host, and this is one host, but there can be thousands of other. It's just an extract. So here we'll define some variables, and basically everything under CO1 is variables. PMC name, IP4, MAC network, etc. And as you can see, they are hierarchized. So I won't go further in that. You will have time to understand how it works. If you practice with Bluebank keys, the most interested of you will easily understand. It has been pretty well documented. It is still living, however, so it's not exempt of bugs. We are all voluntary for Bluebank keys. This is where not really get paid for that. And this is we are partially working on our job because it's used by Atos, but this is not a project that is maintained by a commercial company. This is just a collaborative project that's been initiated by my colleague Benoit Level. Okay. So anyway, don't be worried when it comes to automation and Bluebank keys in particular. You won't be lost during your practice. Benoit will be happy to answer all of your questions, and he will get you in detail in whatever you need. So next time is next thing, sorry, is task. So just to give you a quick overview of what the task is looking for. Okay, what is inside a playbook? Or so this could be found inside a role, or this could be found inside a playbook. It's not the same. It's written the same way, and it has almost always the same form. Okay, so here, if you look at the block, you will see that task has a name. Here, name. We have 3 different tasks here. Okay, we'll go line by line so you will understand clearly. Name install package is just a label to say, okay, what I am doing. This will be outputted during execution, and it permits to have a label something significant for the ones that will review the playbook. The next line, package, is the module name that will be called. Okay, package is a module for Ansible. What is a module? Is something, it's generally a high-level thing that is going to take an action with Ansible. So this one is interesting package. Why? Because it shows you the abstraction. It means, as you understood probably, it is meant to install a package. All right. So we call package module since we want to do something with the package. Okay. We instructed that we want to install a DHCP server, a packet that it's called DHCP server, and we define its desired state. This is something specific to automation. You will define states that you want to get, disregarding its current state. We'll come back to that later. This will be related to something that you will need to understand well, which is called idempotency. We'll come back to that later. Idempotency is a key point when it comes to automation. And I will try to find you a good example, but if not, yeah, at least if you take it down, you will have time to check what is idempotency and what this concept is made for. But just remember of what you see here, state present, okay? And tags is a keyword, also reserved keyword. And here we see tags and package, or every time you see a dash like that, it means that you can create a list. It would mean that I could put 100 of things here that would relate to tags. Okay, it's another way to say one item, then one item, then one item. Okay, you can put dash another item, and everything will be sequentially passed. All right. So here in this example, it's going to be used. It's going to call the Ansible module called package to install the package of the name DHCP server and instruct them that we want it to be present. We could have written absent, in which case, if the packet is not present, nothing will happen. If the package is present, it will be deleted and installed. This is called a idempotency. It means it says the ability of checking something before trying to do it without checking nothing. Without idempotency, which is something managed at the module level, each time I would reiterate over this host, it would try to install or uninstall this package, disregarding if it's present or not. So idempotency is the ability to check that the desired state, the current state, corresponds to the desired state before taking any action. This is clearly idempotency definition. You say, okay, I do something only if the current state is not corresponding to the desired state. It's a kind of a pseudo intelligence that if you do something that will iterate, you can, for instance, if you run a play on a machine and the state is satisfying, you can run against the same group of machine 100 of times, nothing will happen if there is nothing to do. It will just check that, okay. This is how basically an automation works. And most of the Ansible module will provide idempotency. Some of them are not, but they are rare. Most of them are providing idempotency. And if you buy where you guys want to write your own module, you will have to bear that in mind, that you want to provide idempotency. Okay. Now another one is generate DHCP configuration. So here we will call a very powerful module called template. This one is a major module, and it will call the famous Jinja 2 template engine that will parse the J2 files that you can see here and do everything instructed inside, not only replacing vars, but also execute a lot of things. Jinja is very powerful. It has a lot of filters. Basically, almost every Python filter is available in Jinja since it's 100% Python based. And also, the thing is, Jinja also brings conditional, which are not really present. If you look here in this task, you have almost no conditional possible. The only conditional statement that exists in YAML is when, which permits you to conditionally execute a task against whatever vars or vars combination or whatever test. But that's it. Basically, you are very limited in YAML. You are with conditional, and same for iteration. When you attempt to loop over something, you have what you want in YAML, but that's it. If you want to do powerful things, it's gonna be in on the Jinja side. Okay, with YAML, you will just do very basic conditional and more or less basic looping. But looping is already an advanced use of task. It is maybe not the first thing you will want to try, but it is a key point. Iteration loop is a key point. And just a parenthesis in this regard, it's only available for those ones that will really want to use Ansible. Please do not use with item keywords. It is deprecated. So when it comes to iteration, please do not use with item. Do not use with item. Okay, even if you see code examples that's required to use with item, it will work, but it is deprecated. It will not work in the future indefinitely. Now it is replaced by loop keyword, which is much more powerful, works a bit differently. But if you start from the beginning, if you start from scratch, and you want to make advanced things with Ansible and it comes to iteration, please prefer using loop rather than with item. Okay, that's almost it. So here I will go quickly to this code block. Here we are generating a DHCP configuration file. We are calling template module with arguments. You see, everything is separated with two cars. Okay, and also never ever use tabulation in a YAML file. You will get you will get an error. So don't be confused. There is no tabulation in a YAML file, not at all. The indentation is 2 space. That's it. Nothing else. 2 space. No tab. Forget about tab. Tabulation is forbidden in is incorrect character. It will get your playbook to crash. Okay, so here we call module template, and as you see, the indentation here indicate Ansible that is related to template module. So everything which is written here pertains are arguments to this template module. So which argument are we having here? The source template file that we will pass, that will give to template engine for parsing, analysis, and merging. The destination file, the output of the result of the parsing of this template, the output file, the file that will be actually used by DHCP, which will be the owner, which will be the group, and which will be the mode. Okay, And as we've seen with state present, etc. for package, here Ansible will ensure this is the exact setting. It means not only it will generate template file, if nothing has changed, it will just compare, it will make a checksum on this file, on the output file. It will simulate merging template and will compare the output with this current file. If they are exactly the same, it will just do nothing. Now, if nothing has changed as a template, but the mode has changed because someone changed it or someone changed the owner or whatever, this will be unconditionally rewritten and fixed. And once more, if there are nothing to do, there will be nothing done. If the owner is already root, if the group is already root, if the mod is already on 0644, nothing will happen. If just a bit is changing, it will be fixed. If there is nothing to do, it will just go on the host and say, okay. So that's how Ansible work, okay? And same goes for service. So typically here in this task, we do install the HTTP server, generate configuration file according to found in the inventory, merge it, interpret then start the service, enable it and start it. So using service here on a third task, start service, using service will instruct the operating system that started and it's already enabled in systemctl, in systemd, nothing will happen. But if one of those condition of this state is not satisfied, it's going to be fixed. So it is
Yeah.
package management, right? And there
Okay.
are all Linux are not using also the same service configuration. On Red Hat, we are using RPM format. RPM is managed by RPM command or by the upper level yum or by the upper level DNF, but everything is RPM at the end. Okay. The strict equivalent of RPM is deb in Debian. It is both the format and the command. Oh, command is apt, sorry. So the strict equivalent of RPM in Debian is dpkg. It works at file level. The strict equivalent of yum and DNF is apt in RPM. Okay, so all these ones are different. These are different commands, different formats, different things. Okay. So the cool things with Ansible is it provides you with the package module. Package module will abstract for you the underlying operating system. You also have a module called yum and also a module called deb. So it's up to you to use one or another. But if you are using package, you will abstract the underlying system. It will mean that the same task will work for Red Hat, for Slackware, for Gentoo, for an Arc, for Debian, for whatever. It will abstract for you. It's up to him to understand and decide and to abstract, okay, what is under me? Do I am facing a Red Hat? Do I am facing a Debian? Do I am facing a Gentoo or whatever? And it will call under the hood the appropriated corresponding package manager. This is one of the brilliant things in Ansible. Same goes for service module. Some old Red Hat use System 5. Some old Debian use System 5 as well. Modern ones are using System D. Gentoo is using yet another. Alpine will get another. Arc is using another. So with using that, whatever the target, you will have to write only once your task, and you get power with abstraction because you don't have to make specific things. But sometimes you can be specific, and fortunately, Ansible comes to the rescue with its incredible level of power by giving you the most little detail you want on your host. This is called the facts. So facts are, I can say, all the properties, all the metrics you can extract from a machine, whatever the machine. Some of them are more or less facts. But to give you an idea, at the basic machine, Red Hat or Debian without specific things, can return about 1,000 facts to Ansible per host. It means that every metrics, every value, every property you can find for the machine will be available during runtime in your playbook for you to play with. You can extract that from the host. So a fact can be its IP address, it can be its MAC address, it can be the number of drive, it can be the capacity of its drive, everything you can extract. Every property, every value from a machine can be extracted and retrieved from Ansible. And the incredible power associated to that is that Ansible gives you the ability to build one of the most fantastic things you can do in targeting, to build what we call dynamic groups. It means that on top of already existing groups, of already static groups that you have defined in your inventory, it can dynamically extract the facts from all the targets you specify and create group on the fly based on any property. For instance, you say, okay, I want to target for display, I want to target all hosts that have 2 hard drive, or all hosts that are using HPC, or all hosts that are member of this subnet, or whatever, or all hosts that are using this version of Red Hat. And you can combine it that in every way. And you have the ability to build dynamic groups with that, on top of static groups that you will define in your inventory, and you can combine static and dynamic groups together to get the most power of your automation infrastructure. So it's a lot to know, I agree, but at least you know you have this power. It's up to you to take to take benefit of it. Well, let's finish with the playbook before going to PIC-C deployment. Sorry. Well, okay. So this is typically a playbook content. So normally it should contain things like that, but a playbook can be very synthetic and have as the only task just to call for a roles. Here is a typical example taken straight from Blue Bankies that you will see with my colleague Benoit. And here, the only thing I instruct in my playbook, this is the 3 dash. It means that we are dealing with a YAML file. Okay, it's instruct the preprocessor. So the only task I would say I have is to call the roles here. I would just say the playbook name. Okay, playbook name is compute, or this section is compute, and we said, okay, in this part of playbook, I will target all the hosts that are member of MG compute. And on this host, in this part, I will call all these folds. So the first one will set the host name according to variable found in inventory. The next one will set the repository, the Red Hat repository, which are going to be read by you. This one will set up your network card. This one will fill in your host file with all the cluster members. This one will configure your DNS client, the etc/resolve.conf. This one will set up your NTP client to synchronize your clock with time server, etc., etc. And as you can see here, you have one task and an enumeration of calls in the task. So the task is still role, which is a special task which it's instructed to be able to execute all this role content. And here you can see a tag statement. Sorry, I did not talk about it. Tags is meant to specify. It's like a kind of label that permits to have a kind of granularity in the execution of your playbook and execute only a set of tasks inside the playbook. For instance, you want to execute only, I would say DNS client because you updated your DNS server or you change the address. So you will call the playbook with the argument of say, okay, I want only to execute this tag, DNS client. So every other subsequent or previous actions will be ignored. Only what match the tag will be executed against the list of hosts you targeted. Okay, so I think that's it for automation. Very quickly to finish, I will take you to PIC-ACE and how PIC-ACE works and how it will going to be used for deployment. Okay, as we said before, PIC-ACE will be the choice for when it comes to deploying HPC because it doesn't require any interaction, any human interaction with the hardware you want to deploy. So basically, it just consists to start the machine using your BMC, for instance, if you are playing with physical servers. So you remotely start your BMC, and you just let the magical happen, and the BIOS will invoke the network card, which in turn will use its PIC-ACE functionality to send a special packet that will be handled by DHCP, sorry. And so the first thing, it will receive an IP with DHCP in autonomous without having a system loaded. It's something which is managed by an embedded ROM in your network card, and it will get by itself an IP. And then when it will, after having getting these IPs, it will request using TFTP, which is kind of very simplified FTP protocol, to download a bootstrap that will permit it to load a more featured installer that will permit in turn to load the Red Hat installer, the Anaconda. Okay, so let's start from the beginning. So in very first, server will boot over PIC-ACE. We have a blank server with nothing on it, or it can be already installed, but let's start from a server out of the box. You just install it in the rack. You cable your BMC, you cable your Ethernet management interface card, and that's it. After you go back to your office, using IPMI, you power on the node, and you just follow the boot, and you will see that every boot target will fail since nothing is installed. Or if you put PIC-ACE as a first boot priority order, it will go straight to PIC-ACE. And then the network card will send a discover packet to DHCP. As per any DHCP client, it's always start with discover packet, which is sent to the broadcast, because the the client has no IP at the beginning. So as for every DHCP transaction, it will, I would say, it will cry to the broadcast. So broadcast, everyone is hearing it. Okay. Every machine which belongs to the same VLAN with the same broadcast domain will receive this call. Okay, so it would say, hey, I am this machine. I have got this MAC address, and I will require I send a DHCP discover packet because I am requiring an IP address from you. So DHCP will catch this broadcast. Here we can see here DHCP, which is replying this packet that has been sent initially to broadcast, and it will send an offer packet. This is still standard DHCP for now. Then the machine will send a request signifying to DHCP that, okay, I used the IP you referred to me. And the DHCP will reply with an ACK, what we call ACK, an acknowledgement, to say, okay, I understood. Roger, in other words. Okay, here's the ACK. You can see, or we can go back. Okay, here, okay. So discover, the packet is sent from here to every host. Everyone which is member of the same broadcast domain will receive the packet, since it is written to broadcast to global broadcast, I mean 255.255.255.255. Okay, so all machine will hear it, and only the DHCP will say, okay, this is a DHCP discover, so it is something for me. It will look in its table, in its configuration. Do I have a reservation for this MAC address, for this hardware address? If it has a reservation, it will assign the designated IP in the reservation. If it has no IP address, no reservation, and it has some free lease, some free IP leases available, it will assign an IP leases from an IP from the free leases range. So discover, offer, which come from DHCP to the host. Then the host is sending confirmation to say, okay, I received this IP. Is it what we want? Okay, I request officially this IP, and the DHCP say, okay, acknowledged. You are actually using this IP. So it is just meant to make sure that that the IP has been assigned to the right MAC address to avoid spoofing and so on. Okay, so now the next thing is that the DHCP has been configured in this option to instruct client on the location. We call that the next server option. Next server is a standard option from DHCP that instruct a DHCP client that require it that, okay, if by ever you need, next server is here. Our next server is an option, a standard DHCP option that refers, or it will always refer to a TFTP server. Okay, TFTP stands for Trivial FTP Protocol. So DHCP will provide the next server IP and assigning the path to go to download the bootstraps that will be then executed to boot and execute the installer, the Red Hat installer. Do you have any questions regarding that or what?
No questions, please.
Okay, fine. All right, so I come to the next part. So once the file name has been given by DHCP and has been received, the client will attempt to execute this bootstrap and then call finally the Red Hat installer. So it will download a kernel and initram fs, and I mean a kind of init rd with providing the URL I will be provided, sorry, the URL to download this kernel and in turn execute the installation, the Red Hat installation process. Then, sorry, okay, Pixel. Okay, well, the client grabs the packages. It will receive the list of packages from Red Hat, grabs them, and instructs the installer to execute all these packages, to format the file system, to partition the disk and format the file system and copy the file on them. Okay. Is that process clear for you now?
It's okay.
It's okay. All right. Fine. Okay. So I hope you appreciated this course. And sorry, I could not be more precise on illustration. And so it's really a best effort. And well, we did
Yes.
our best to be more or less exhaustive. But I'm very conscious that due to the lack of preparation and the very short delay we had to carry on that, it was just not possible.
Thank you very much.
All right, guys. So enjoy your day and take care, guys. Ladies and gentlemen, have a nice day. Cheers.